Good morning, everybody. It's definitely morning this time. We're up early. God. Good. Let's go. Right. Yeah, what are we doing today? So, more placement history / logging stuff. So, yesterday, we had bundles of fun trying to create the file at the right time for which log entries are going to be stored in. We did this. Where is it? Let's have a look. In here. Yes, here, somewhere in here. Somewhere down here we have the log file. Let me find it. Just do a record phase operation when you start something. Yeah, this one. So when you record a placement operation, it says no, not that one. Oh, I can't even find it now. Record phase operation. This is one, not placement operation. That's it. When you start the first phase on the job, where you prepare the PCBs, that's where it happens. It says, yeah, that's what we did. Amazing. You'd think that'd be easy, but no, that took all day. That did. Why did it take all day? Well, because we needed to introduce like phase operations. That's what we needed to do. So now we've got phase operations. Let's have a look at a real-world example of what phase operations looks like. Okay, so here's a project, and it's got phases. Here they are, right? Top and bottom. Great. And then you've got some state now. And there's this operations state in each one of these now, which didn't exist before. It was in the report, but not in the project. But now the state is in the project. And of course, every time you do a placement, you have to update the state. And if you assign placements to a phase, then you have to increase the total, because it either gets assigned to this one or it gets reassigned from another one, right? So you have to update all the states. So all that got done. That was quite a bit of work. It also did a whole bunch of refactoring, because the project report thing was like a giant method, of course, which we knew that we needed to do some refactoring, but we didn't want to do it too early. But it felt like a bit of a good time to do some refactoring yesterday. So now in our report code file, we've got various different methods to allow us to generate report and then build the various different things that go in the report, right? So that all got extracted out. So it's a lot better now. Yeah, and I also reviewed some of the iterator usage, improved some of the error handling, and so on. The details are in the commits, obviously. Yeah, this was quite a big one. So lots of extractions and things like that in this one. I'm not going to go for that. It's not terribly interesting, but it was useful nonetheless. Anyway, so today we're going to try and actually write some things to this log file. Now, so create a log file path. Let's just run this and look at the test results for number 12, or number 11 rather. Was it here? Yeah, this one. Right, so this is what we're printing out. So create a new log, and then what we said was we're going to use a JSON file. But I'm not 100% sure about this yet, because of the log files in JSON. You see, the problem is JSON is a structured document, right? So let's think about this. Look. So say we go say you create a new log entry, what's it going to look like? The file's going to look like this, and you want to create a new entry, you just go, I don't know, it's going to be something like this, right? And then like time with a thing in it, and then date, I don't know, message. Let's just say these two things as a basic log file, right? And yeah, for some of the other ones there might be some more information that goes in it, and it might be useful to pull it out, like, I don't know, the object path, for instance. Right, and so on. And depending on what it is you log in, you might have fewer or more fields. Fewer, not less. Exactly. Right. And then you go, fine, okay, saved it, done. And then you come to add your next one, right? It means you've got to parse the whole file to put a comma there, and then add another block with more stuff, but without the comma, right? So you can't just append to this file like you can with like a CSV file, for instance. You have to read it in. You can't just seek to the end of the file and then write some data, because it's a structured log file. I'm not entirely sure it's a good idea to use JSON for this. I wonder what other people do. Now, granted, you could create a text file, right? But then everything in the text file has to be very precisely formatted for any type of machine to be able to then later read it. And we want this to be a machine-readable file, not a human-readable file. Its primary usage is for a computer to use, for a machine to use. Why is a fair question. Why does it need to be a human, machine-readable file and not a human-readable file? Well, because you're going to want to load up the previous history and look at all the parts that were placed. And then maybe you want to attach photos to it from optical inspection as a later process. So then you've got somewhere to to capture the data and store the data, for instance. So maybe it does need to be a machine-readable file after all, and everything's fine and I'm worrying too much about it. Let's just go with it. Fine, it's JSON. We're going to deal with the fallout. Let's go. I mean, like, how many placements are we talking about? What's the speed of these computers? They're quite good at doing this stuff these days. It's not like we're running lots of these operations all at the same time on one computer, is it? It's just like, no, you've got one machine doing one thing very infrequently. It's probably fine. Okay. So, given the fact that we now decided it is going to be a JSON file, we should probably try and read it and assert that something is in it. So, as part of recording a phase operation, in addition to the placement operations, we can add log entries, right? Yeah, okay. So let's read it in. Let's read it in. This is how we read a file. Let's go. Log content. Now, do we just want to read it in like this, or do we want to actually try deserialize it? We probably should try deserializing it, really, because then at least we know we've got a JSON file, right? So let's not do that. So we want to deserialize something. So I suppose we have to refresh our memories on how we deserialize things. I guess we need a deserializer, we need an object, and so on, right? I don't know. So yeah, let's try and remember how we did it somewhere else. Let's search for deserialize. Right, so we've got some CSV deserializing, but that's not really what we want. The project does it, doesn't it? Okay, let's look at the project. Project. It's not in the stores, it's in planning, and it's project. And do we have a load thing somewhere? I'm fairly sure we have a load project somewhere. We call it enough times. Alright, here we go. Where is it? Okay, I can't find it. Let's look for it a different way. Project load. Here it is. Okay, that's how we deserialize something. Okay. So in our test, we're going to schlep that in there. Right, and then we're going to change some things. Let's go from what we actually want to do. So we want to deserialize the log. So what is this? History log? Seems reasonable. History log? Operation log. Operation, or is it operation history? Let's go with operation history. Because it's not really just like a log at this point, I guess, now that we've decided that it is going to be more structured. We'll go with history. So we're going to say operation history deserialize. In order to deserialize, we need a deserializer, and we create a deserializer from a file. Which means we need a file, and it's going to be using this path, right? And everything's good. So now we need this operation history object which we can deserialize. Now we've got a problem. Okay, because we don't know what the root elements are going to be. I mean, we can create an enum for the root elements, and it'll work. But we want it to be an array. Because there is no one object. Well, I suppose there is. Let's say let's see if we can work it out. So if we have a structure called this, right? And if you want the things in it to be an array, what can we put in this structure? Is it entries? And then what's it going to be? A vector of operation history item or something like that, right? Item or items? Items versus entry. I'm doing items because entry is normally reserved for maps, but you know it's not always. But in Rust, it is. Okay. So what is this? Phase operation? Because we're recording a phase operation, right? I mean, is there common stuff to every single log entry as well? Yes. Yes, there is. So really, this needs to be a struct with date time. Let's just make this a string for now because I don't want to go into the world of date times just yet. All right, and then we'll go something like this. I mean, what's this going to be? Is it just going to be a hash map? Yeah, okay. But you know, if you want to process these things, a hash map is not great. But with JSON, it's like key value. But I don't want that. You see, this is the problem. How are we going to do this? How are we going to do it? Don't know. I mean, if we said we've got an operation like this, then it can be a operation history operation. I don't know. Detail, operation history detail. No, I don't really like that. Kind is what everybody uses in Rust. What is this? And what did we actually say that we did? It was load PCBs. Well, maybe there is nothing else that goes in here, and the name comes from that. I don't know. There's so many different ways you could go. Let's take a first stab at it and we'll see where we get, right? Why am I doing this here? I'm being silly. Right. So the name will be contained with this, and yeah, probably, you know. Is it that? Who remembers? Yeah, no, that's right. Okay, the ID wasn't keeping up very well. Okay, so operation history deserialize, yeah. Not sure why it's getting a bit confused by that. Let's see what it does. Operation history deserialize. Operation history derive deserialize. Probably because we need to import it. Okay. Let's borrow the... Let's borrow these. We're going to move this somewhere else at some point, but oops, it is. Okay. Does it build? Well, it builds. So, you know, we can have a crack at writing that and then deserializing it and it might work. We'll have a go at it. Okay, so these structures don't contain the word test at the start of them, right? So they're perfect for copying and pasting into production. And then we can come back and add the word test to each of these so that we know which ones we're dealing with. Okay. Let's see what we can do here then. Well, I suppose we need to add an assert still, really, don't we? Let's say operation history dot. Okay, we'll add the simplest assert we can. There we go. We're going to say it's not empty. Right, let's see what happened. End of field. So end of file. Right, so it didn't deserialize anything, which means there was nothing in the file to deserialize. And you see, here we are, just... I'm not entirely sure about this at all. Like this whole items thing, like this, I just don't like this. It's pointless structure. Right. Now, luckily for me and everyone else, I have done this stuff before. I didn't like the way I did it before, but I'm going to have a quick look at it and refresh my memory, just off screen, just slightly, while I try and remember where it was. Yeah, I've had to do this before. We have vector of things. Well, did it end up being the same anyway? I was doing TOML stuff before, not JSON stuff, but it's fairly similar. Yeah. Yeah, I had to write a custom deserializer for it. Yeah, I didn't really like it. Yeah, it was bad. Didn't like it. Didn't like it at all. Let's see if there's a better way of doing it. Okay. Not sharks. Let's have a look. What are we looking for? Survey JSON deserialize file with array in root. Something like that. Yeah. How can I deserialize a JSON with a top level array using Survey? That's what we want to do. That. Okay. Alright, so maybe we don't need to create an object for it. Okay, we just go from stir. Okay. Alright, maybe it's not so bad. Maybe it's not as bad as I thought it was going to be. So instead of doing this deserialize like this and using the deserialize from an object, let's try and delete this, right? And then say well, I don't know. Let's comment that out. Survey JSON from reader. And let's comment that out as well. And then say let operation history, which is going to be a vector of this, is going to be that. So now we can get rid of this items thing, right? Can this fail? Probably. Let's try that. Because we don't want this silly items thing, it's crazy. Okay, now what happens? It says EOF while parsing a value at line 1. I mean, this is good. But can't, yeah, I suppose. Okay. So what's happening here is that because there's nothing in the file, not even the array, the empty array, it's dying. But I don't really. I just want, if the file's empty, I just want an empty array. So this gives us a result, right? What can we do here? I suppose we can say, or, and then we want to have one of these. But that would capture like every single error, which I don't think is what we want. So, you know, that we could do that, but I don't really like that. So what else, what if there's a map? Is there a map error? What do we want to do? I don't really want to map it. But if the error is like a specific kind of error, I don't know what kind of errors you get though. It's like, it's not really clear. Because we've got this EOF error, but I don't know where that comes from. Like if it's this error, then we just go, okay, have a default instead, right? If it's anything else, we report the error. That's sort of what we want to be doing. Here we go. That's where it's coming from. I mean, you see, we don't want it. We can't stop on that either because. Okay, look, fine. We don't need to worry too much about it. We're going to just let the error bubble up. It's fine. I don't want to be going into the details of looking at the results and checking to see if the error, which particular error occurred, and if it was at the first character of the file or whatever like this. No, because if we've got a sort of semi-truncated log, it's going to give us the same error message, like EOF at whatever, and then that will be, we would want that to appear. So we're just gonna do that. Fine. So what that means is we need to write something to this file as soon as we create it. So this is where we say we're going to create the file. And we do this. Right? But I think we need to do something else. So let's go to planning and create a new mod called, what is this, operation history. Sure. Right. Now in our tests we had these operation history thingies without the test prefix. So let's just grab them for the moment, stick them in here. Yeah, that one. Right, and then we're going to put the word test in front of these, so that we know which ones we're using. Right, and then we're going to take these out of here and put them somewhere else. Not quite sure where. Let's go pub mod operation history. And we're going to schlep them in there. Okay. And where we've got this serialized thing, we need to cut them out of there, I think. Go to the operation history, paste them in there. Go to the production code and paste them in there as well. We don't think we need deserialize. Here we're going to need serialize. We are going to need deserialize, so I'm just going to leave it in for now. Okay, something like that. I don't know why it thinks that's unused. I'm clearly using it, but there we go. Right, okay, fine. Fine. Right. So, in this, we can now do the opposite of that other thing. So where we're recording it, here we go. Then we need to, oops, daisy. Oh. These need to be public. Come on. Why is it not finding it? Is it just being slow? Or is it... Yeah, it was just being slow. Okay, fine. So this is how you read it. So we need to do the opposite of this in the production code, right? So let's grab those for a moment. And just plop them in here for a moment so we can see what they were. So we don't need to create a new file like this. We want to do it a different way. So let's see what we can do with serd.json. To writer. Right, we get a file like this. Maybe we do want to create it. And then I suppose we need to give it operation history, I suppose. And then just make this an empty one. Right, but these are not currently public. These are going to need to be public. Okay, so we've got operation history, which is a vector of these things, and then we're saying to writer, and we've got a reference to these things. There we go. I don't like the way it says creating, because that kind of makes you think that it is going to do something. So let's say created new log file. Past tense. Okay, right. And then we'll go back to the test. somewhere over here. And we'll fix that up as well. Created. Is log created operation history. Yeah, let's do that. Create a new operation history file. There we go. So if we have that, let's see what happens now. It should be alright now, right? No. What does it say? Oh, well. It's empty, isn't it? We're supposed to put something in it. So updating the phase operation. Yeah. Okay, this can fail and we're going to get bad error messages. Let's say fix me, use a context. For better error messages. Because we did this in those loaders, didn't we, in the stores, if you remember that. Like, because it said file not found. It's like, okay, but which file? What were you doing? So if it failed to create the file, it would like, unable to create file, and you'd be like, okay, well, what file and why? So we need to add that context thing. So we'll come back and do that. Right. So, you know. How about we say, you see, let's extract this. Create. Should we say create? Yeah, okay. Where did that go? Like, that's twice it's done that now, look. My IDE is getting a bit confused. It created this method correctly, right, but then didn't call it in the call site. Well, this is very silly, isn't it? Okay, look, let's put this in the right place. No. Okay, this one does need to be mutable. Phase log path. That doesn't need to be mutable. Operation history, and you might get an error. Okay. Let's see if we can call that method. Well, I suppose it needs to be public, doesn't it? So you create a history, and then you say create a file. Should it just be store? Should we overwrite it, or what? Do we really want separate methods? How about we take this message and right, we've got it there, and then go saved or wrote generated, not really, updated. You see, like, because like create, I want to know if the file exists or not. Okay, can we go phase log path exists? We can. Okay, so we've got create files. I want to create a file. Open file write only mode. But it create new. Error if the file exists, right? But I want to know if it was a new file to tell a user that. Do I really care about that? Would that just be a little improvement? It probably would be. Okay, fine. We're just going to go. How about if is new? Oops. Then say this. Otherwise, updated. There we go. Fine. And then, you know, it's not very rusty, is it? Bit more readable. Fewer little curly braces. Happy days. Okay, fine. Okay, so we can create a file. Should we just call this store or write? Let's call it write. Planner. Oh, not there though. Right. 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 Okay. But we haven't written anything to it yet, so we need to put something in this list. Well, I suppose we can just create it in line here, can't we? operation history item with some fields. Let's say now. Yeah, I suppose we've got to come back and fix that. Operation, what's the operation? This is operation history kind. And why has it done that? Don't do that. Load PCBs. Because that's what we said we're doing. No. Well, I mean, we've got the operation. Oh dear. So I suppose we need to go operation like this, right? And I suppose we need to match over these and then create the appropriate history item, right? Oh dear. Sure, you know, and we'll just repeat this for the rest of these. And we'll just have a one-to-one mapping on these things. Load PCBs. Automated whatever. Alright. Oh, we need a semicolon. And this needs to be mutable. Push immediately after creation. What's the problem with this? Well, let's extract this. There we go. So I suppose here you should be able to go vec of this without mutating it. That's what it's moaning about. Fine. Everything's fine. Okay. But it's not as simple as that, because we're dealing with load PCBs here and we're creating a file, blah blah blah. But this can be cool for other reasons. So we need to move this here. So we've got a history operation, and we've got a history item. Oh yeah, okay, fine. Right, so this will deal with generating it, but if we try and do something else and record another operation, it's going to overwrite the file with a new one. If it's load PCBs, otherwise it's going to not do anything with this thing. We don't currently have any asserts for that. Yeah. It's probably good enough for now. Until we add some more asserts. Oh, it's not good enough for now, apparently. It didn't work. Okay, so it created new operations history file, which is correct. What's the problem? So the content is created. Oh. Well, if it's created, it's obviously new. It's a bit redundant, isn't it? So we'll just... And ta-da! We've recorded something. Well... yeah. Alright. Let's look at this operation history for a moment. So these are the sort of like operations that you can do. But there's also other things that we need to record that we said earlier, which was replacements have been placed. We don't currently have any asserts for those. We don't have any asserts for anything else other than load PCBs. We're not even asserting the load PCB one is correct yet. So let's update the asserts and make sure that we actually wrote the things we wanted to write. So record phase operation, this one. Okay, so currently we're only saying it's supposed to be empty, right? But what we really want is to say well, pop. Is there a pop front on a VEC? No. Because this takes the last one off it, really, doesn't it? Can we go first? Split first. Let's go. How does split first work? Yeah. Okay. Let's have a look. First and then elements, yeah. I mean, I could do an if-let, but I don't really want to do an if-let. Because this is a test and I want to assert it, right? Let's say... and do this. I suppose we can go... oh yeah, okay. Yeah, we can do this in a tuple, can't we? And then operation history, yeah. We call it unwrap here, right? There we go. And then the unwrap will fail in the test. So the operation history, the remainder of this is supposed to be empty, right? And the first one is supposed to be one of these test operation history kinds. Sorry, item. Why is it moaning? Test operation history item. Just fill in all the fields. Is it because none of the fields are public? Yeah. How about now? How about now? There it is. Go on, catch up IDE. Let's just say to do. Still got to do that one. And our test one has only got one in it at the moment, and that's the one we're looking for. So that's fine. I don't really. Can we do that? Oh, that's what I want to do. Why is it moaning? Remove the comma. Oh yeah, okay. That's interesting. Wonder why it doesn't let you have a comma here. History item. Okay. Well, you can't have default on that. I just want to create the new. Okay, fine. Fine. Right, so we don't have equals on here. So we're going to need it partial EQ. We're going to need it on that and this. Do we need to do a reference to this? Yeah, there we go. Okay, so it's failing because... Yeah, so the time and date. We've got a difference in the time and date, so that's fine. Let's try putting the time and date in now to just sort of button this up a little bit. Who knows how to format a date in Rust? Oh god, here we go. Can of worms. Dates and times. Do we need a library? Gah. Fine. I mean, how are we going to assert the date and time is going to be right? We don't know what date and time the log file was written at. and we don't really care, just as long as there is one, and that it can be parsed. Yeah. So, comparing it, no. So I suppose let's get rid of partial EQ of here. Not going to do comparing. Now we could implement our own partial EQ and ignore the date and time field. Not sure that's a good idea. How about we add like some test helper method for just the operation. Let's just assert the operation. Is that all we can do? Operation kind test. Operation history kind found a reference to it. Oh, I see. Let's not pull it out. Yeah, okay. We've ignored the date time, but the problem is the date time is wrong. Now, if the deserialized thing has a proper date time field in it, and the deserializer knows how to deserialize date times, you would get a deserialization error when it tries to read the file. So we don't need to specifically write a test to say that the date can be parsed. What we just need to do is change the type, I think. Right, so we've got this this thing, and it's got this. But if we say date time, I don't know where you get time. Don't know. Date. I don't know. Suppose we've got to look it up. Date times in Rust. Let's go. My first one. Might not be the first one. I might just have forgotten it. Date time. There's a chrono library. Yeah, we've got this instant stuff. Yeah, there's this chrono library. Because Because I think they specifically didn't put date time in the main standard library because date time is such a faff that the world can't agree how to do it properly. Date and time. So there's two ways you can do it. I knew this to be a can of worms. Like, so we've got chrono or we've got time. Time seems to have more downloads, but they're very similar in terms of like recent downloads. So I don't know. We have to pick one and go with it. I don't care. I don't understand these projects, right, that go time. It's a date and time library, fully interoperable, yada yada yada. And where's the overview? Just give me an overview first. I don't care about the minimum supported Rust version. That's the detail. It's like, give me the overview first. Like, what does it do? What's the purpose of this library? Like, come on, people. Let's have a look at Chrono. You see, look, this one has got an overview as the first thing you look at. Right? So in that regard, it makes me want to use this one straight away. Because I have no idea what the purpose of this crate is. Right? Even though it's more popular, it makes me want to use this one more. What does it do? What's it for? Let's read this. Do we care about time zones? I mean, clock, superset of now. Okay. Well, it's got Surday support. I mean, this is good. See, leap seconds. Date and time is just like a nightmare for computers. The common epoch. Nanosecond accuracy. Woo! Okay. Okay. There's a book. What's a foot gun? I don't even know what foot gun is. Foot guns. Curious. Okay, let's have a look. Rust. Chrono versus time. If you don't need... Oh, good lord. Personally use time for new projects. Time is better maintenance record and is more lightweight. However. Oh, good lord. Oh, good lord. Interesting. We don't need to do any time zone conversion or anything like that with this. It's literally just like slap things in a file and away we go. What is this? Huh. Who knows? Oh, that's interesting. I'm just going to go with time and not this chrono one. Okay. We'll see how we get on. There's lots to read. There's too much to read. You've got to make a decision. You can sit there reading all this stuff all day. At some point, you've got to make a decision and just run with it. And that was it. Decision made. There's no real sort of major points either way. But the simplest one, people said time was simpler, and they didn't like chrono, and they weren't good examples, and it was slightly unmaintained for a while. So I'm just like, I'm going to go with time. A couple of people said time for new projects. Who knows? I don't know who these people are, or if what they said has any weight whatsoever. But yeah, we're just going to go with time. And let the chips fall where they may. Okay. We did it. It's done. I don't know. Does date have a time in it, or is there a date time? What about a time? Does a time have a date in it? You know, these are the things that I'm just like, I don't know. Back to the manual. Types. Let's have a look. No. Past dates. Create dates and times, I suppose. A date. Right, it's got a date in it. Fine. What about a time? Time. So then, does a date? I still don't know if a date has a time. What is it? It would be helpful to know what this type was. Don't you think? Don't you think? Okay, like. Macros, alright. Sure. Oh dear. Okay, yes, the technical reference is really, you know, the table of contents would have you believe that it's well documented. But if you click anything, there's not actually a lot of documentation at all. Oh dear, oh double dear. No. Okay, maybe it's just not in the book. Maybe all the documentation exists somewhere else. Time. Date. Oh, the clock time within a given date. What? What do you mean within a given date? I just want to know what day something was on and what time it was on at that date. Do I want a date just by itself? No. Do I want a time just by itself? No. I want the two things together, a date, time. But is it called date, or is it called time, or is it called something else? Okay, so structs. Here we go. We've got date, we've got time. Am I supposed to like have a type which contains both? Is that what I'm supposed to do here? Date. Like year, month, day, week, blah blah blah. These are all the kind of things that you want a date, time to have. Futzing around. Oh look, we've got this with time. It's got primitive date time. Okay, we're going to try it. It's fairly isolated and self-contained at the moment and hasn't spread like a cancer through our code base. So we're just going to go with primitive date time and see. So you can create a date time from a date and a time. But there's also a macro to let you do it. So we do this, I suppose. What happens? Is there a now? Date time. Do I have to ask the clock for now? Good lord. Okay, right. First things first. Let's see what happens if we stick that in here. Right, go. Right, because it should fail, but we get a compilation failure. So, right, so we probably need to update this and add a feature called serde. Yeah, okay, it's got serde as a feature. So we do that, and then we run it again. Okay, and it should fail with a parse error or something like that, right? Invalid type string 9, expected primitive date time. Okay, good. Now let's poke the production code so that it also has a primitive date time. Okay. And this, I suppose, is now where we need to magically work out what the time is now. Let's say now. No. Let's do it like that. And how do you create one of these? How do you get now? No, you see we're. Oh no. Feature flags. Right, sure. What's the time? don't understand, like, devs that don't understand their users. What is it? How do I use it? What are the most common use cases? Show me the examples. Right. Yeah, you see now that I've said that, I'm gonna have to make sure my documentation is up to date with this program. Yeah. You should just be able to use it without having to write any documentation, though. For a program, but for a library, it's a little bit different. So we don't know how to get the time. How do you get the time? I mean, do we have to go and look for a code example? Do we think that there's an examples directory? Place your bets. Place your bets. Everybody place their bet? I'm gonna bet no. Ha! I was right. There's no examples folder. Oh gosh. All right, fine. Oh dear. I just want to know how to get the time. Tests, alright. Macros. It's probably a macro. Formatting things. Just get the time. Main. Okay. Run with all features. Yada yada yada. No. How about time? I can create a time. Yes, that's not what I want to do. I want to get the system time. No. Is anyone else finding this hilarious? I mean, where do I even start looking? You'd think that it'd be somewhere in the test, wouldn't you? Like macros, formatting, errors, main. We look there. Meta, month, parse. No, just it wasn't in time. You can create it from the different things. I mean, there should be like sort of conversion or whatever, but no. No. Time core maybe? Source? No. What about macros? Date time? Parsing? Token trees? No. Quoting time? What about this? Period? Parse? No. For fuck's sake. Jesus. Tests. Digit count. I don't care about digit counts. Offset date. Primitive date time. Let's have a look here. Primitive date time. Large date. Okay, well, how do I get the time? New. I can create a new one from the date and time, but I need a new date and I need a new time. Just beggars belief. See, look, it says new, right? And I have to give it a date. Date. Now. Just now. Can I have a list of macros? Now. Fuck's sake. Stupid library. Am I going to have to search the code base to find out how to get the time? This is what I'm resorting to. Now. No, that's timing a function. No. 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 Now, what's this? Instant now. It gives us a standard instant. Only useful with duration. Well, it's just madness. Offset date time. What's an offset date time? You've got primitive date time, you've got offset date time. I just want the time. System time now into. We've got an offset date time. Should I be using offset date time? What's the difference between primitive date time and offset date time? It's probably got a time zone in it. Okay, so like, let's just go offset date time, because that's the only thing that seems to have some way of creating it from the system clock, because I couldn't find it here. Sure. There we go. Like, what are the now functions are there? We've got add, from, sub, got now local, and now UTC. Should we be using UTC in logs? Probably, to be honest. Just gonna go with it. Honestly, date and time. You would think it'd be easy. Nope. Was it local date time? What was it called? Offset date time. Okay, let's go back to the structs. Offset date time, primitive date time with a UTC offset. Fine. We're going to go with that. It's fine. What happened there? Oh my god, the test passed. Let's delete these things that we're not using. Oh. Yeah. Yeah, we've got them explicitly. And same goes here, yeah. Love the way it does that. Alright. Who knows what we were actually doing? This one, I think. Called a phase operation. And we said... Oh, excuse me. We said the expected operation was this. Yeah. Yeah. So if we move this up, because this is supposed to be somewhere here. Right. Yeah, something like that. So there should be only one, and that's it. That's what we're saying. Right. Jeez. All right. It's time for a commit. Sometimes programming computers is a frustrating world of pain. Other times, it's very satisfying and rewarding. Learning how to use a new time library to do something simple as to get the time and having to make choices in order to tell the time is not one of the more fun aspects of computer programming. Right. So my thoughts after using the time library to store the time were that I didn't like my experience. Not one bit. The only bit that I did like was the Surday feature was called Surday and it worked. The rest of it I was deeply unsatisfied with. I didn't like how I couldn't find things in either the source code or the documentation, even though I was trying to read it quickly. I mean, that's the point. I was trying to read it quickly to get to the information that I wanted, like quickly, and just go blah 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 blah. No, can't find it, because that's what you have to do as a developer. You just have to look at a page and go, no, it's not on that one. No, it's not on that one. No, it's not on that one. And then, if you can't find it almost instantly, because after a developer you learn how to read all these documentations. If you can't find it almost instantly, then you're like, well, okay, now I've got to dig deeper. But most of the time you shouldn't be forced to like really go into the detail of it and read every single part on the page. This is how I work anyway. Maybe other people look at a bit of documentation and read every single word, and I don't have time for that. No pun intended. I don't have time for that. I don't have time to read, like, you know, go onto this and like read all of this from top to bottom. No, I scroll through it and I go, does that look like what I want? No, it doesn't help me. Great. Okay. Where's the information? Where's the examples? No. How-tos? No. Okay, and then you have to start looking a bit deeper. And then you're like, okay, well, I've got dates, I've got times. You know, my first look, I didn't see these date time things. I was more interested to know whether date had a time in it and whether time had a date in it, but they don't. But it's often not clear with these things. And then the next thing I was doing was then, you know, trying to find something that did have both a date and a time and how you create it and so on. It wasn't obvious. And then I ended up going primitive date time, but there's no now method on here to actually create it. And the first thing I looked at on here is not like, you know, a quick example of how you're supposed to use this, like top level module documentation for an API is quite important. For an API, it's important. If it's like some detail of some program that we're creating like we are today, then, you know, the module documentation it's only intended for developers who are working on the code, as opposed to a consumer of a library who needs to know how to use the library and why they should be using it instead of any other library, for instance. And like, give us an example, right? You know, and then I looked in the repo for examples. No examples. Scroll down. No examples. Go to the book. Create dates and times. Sure, but it doesn't say how to get the time now. Look. Now. Searching for it. It's not there. Create date and times. I mean, one of the most common things you do is ask the computer for the time. Right? Parsing stuff, fine. Construction, empty. Bad experience. Right? Right. This book is useless. Useless. To me. No. I want to see what it looks like with Chrono. I want to try the same experience with Chrono just to see. Right. Okay, let's do the commit. So we've got time. Right, what dependencies did it bring in? Oh, it was already there. Do we think Chrono's already a dependency? It is already a dependency, so it doesn't matter which one we choose. We already have it as a transient dependency, which is, you know, a thing. Right, so what do we do here? Let's do a commit. So we expect a test operation history kind. We change the log. Yeah. So we're going to say log, and I'm going to be very specific on what we actually say that we're doing at this point. Log an operation history when setting the load PCBs operation. Now, there's some problems with this. It's not quite finished. When setting the load PCBs operation to completed. Load PCBs operation to completed. Now, there's something missing that I just realised here, which is this phase. It's missing from our log, so we need to come back and fix that. Well, it's not really fixed me. This is a to-do, isn't it? It's an improvement. It's not broken. White space changes. I'm not sure why it's got these white space changes in here, but there's quite a few of them. We're just going to go with it. We'll clean them up. It seems to me that the editor, when you extract like a method or something, or do that, it adds white space. When it does the refactoring, but it shouldn't. There might be a bug in the refactoring thing, because this method here was extracted from another method, and when it extracted it, it put spaces in it over here, which now that I've edited this file, my editor's going to come along and remove these ones, but it doesn't trim trailing spaces after it creates the method. Which is a bit annoying. Right, so we create an operation. Right, we have to add all of these ones in here because otherwise we won't be able to create it, and then we have to start doing, if we've got this, then do that, which I don't want to do. And then we're writing it. Yeah. Yeah, okay, fine. Right, so what we've got to do in this is record the phase as well. Is there always going to be a phase for every operation? Yes, because operations are related to a phase. So, fine. Pub phase. I think it's a reference like this. Yes. But this reference, well, let's just make it a string here. Right, but in the production code, we need to go pub phase reference. Right, and somewhere we're creating one of these. There it is. I like the way when you do that it puts it in the same order. So we've got this update phase operation and we've got the reference here. So we can go reference, phase reference, and clone it probably. And then we probably should have done this earlier. Update the expected operation. You see now we need to look at more things. I'm in two minds now. Okay. Let's just add an assert here. Go. I think it's top one we're doing, aren't we? Yeah, top one. Okay, so we've got the phase in there now. Great. So we've got an operation and this. Now, I had on here these, and I think we're going to get rid of them until we know what's going to go in them. I'm fairly sure that there's going to be stuff that's going to go in the in some of the other ones. It's probably fine. So yesterday, when I was doing some work on this, we had a completed flag on the operation. And the operation can be marked as completed, and then you can go and add another placement to the operation, for instance. And at that point, because you haven't placed it, the operation then becomes incomplete again. So what our test isn't testing is the state of the operation. So maybe we should have a completed flag here. Right. Okay. Yeah, it's a bit of a faff. It's a bit of a faff because we've got to change the operation state and we've got to log it, and we probably shouldn't be doing some of this until we've done this. We don't know what it is that we're going to log or set or do Should we be logging the operation set items? Yeah. It's just going to be the same for each of these. I'm trying to find a good place to put some of this code, because I need to put this completed flag, oops, in here, right? But I don't have the completed flag. Let's pull this out and put it here. And maybe we have to load it up at some point, right? Now we're not using this history item at all. So if something happens, then you need to do something. So let's just do this in a block here. Right. But it do operation. And then the operation here is a process operation kind. And let's say we always write it, which is probably going to be wrong. Right, we don't really care about this, but we can say no, we can just go, we can use that now. Okay, fine, that's not too bad. So we can ditch that. And then we've got to add the history item to the log. Operation history, push. But now it needs to be mutable. Operation state. We've got, why is it moaning? Let's run it. Is it this? No, we want to do reference now. We want to. This state is this one, but why do we need this state? Right, okay, so we're modifying the state here. But why do we need to... Okay, should we be doing this? Is there a .get mut? There is. Can we do this? Because we don't need to get it twice. Yeah, we can do that. Right, let's have a look. Why has it failed? Invalid type map. That was the last error message that I thought that I was thinking we were going to get. Yeah, okay, it's probably because this is supposed to be completed here now. Yeah. Yeah, okay. Yeah, okay, that makes more sense. Just forgot to add the test assertions. Okay, so we record the fact that it's completed. Magic. Is that what we wanted? Let me go back to the... Let me go back to this. So we say... Get the mutable state. Suppose we can move this down a bit. I suppose we don't need to do this unless there's something to do. Yeah. Okay. Because for now this works, but in the future we're going to need to load the operation in history instead of going like default here, right? But we're not there yet. It does what it's supposed to do. Okay, so let's try this. I can't find my thingy. Where is it? This. Okay, so this is a real world example, and we have our little MD file with a list of commands that we used, and we're going to record a placement operation. No, we're not. We're not doing that, are we? We're doing the other thing. So we're doing this. Okay, so we're supposed to be going record phase operation. Oh, look, and it created it. Yay. Okay. So if we cap this out, or display it on the screen, we see a little JSON log file. 2024. What is this? Two, 3, 5. I mean, sure, you can serialize it. 235. What part of a date time has 235 as a number? Like, I know it's a machine readable file, but come on. And then what time is it now? It's 10:31. That's probably what this is, the time. Is it day 235 of the year? 8:29? I mean, that looks like the... No, it's 8 is the month. But what the hell's 29, 51, 235? I mean, the internal format of this I don't really care too much about. What I care is about if I just quickly look at a log file and see a date in it, it's formatted in a way that makes sense to a human, even though this is a machine readable file. Because at the moment this is a machine readable file, but it's only machine readable by something that knows the internal data structure of a local date time structure implemented in Rust, and that is far too specific. We want a formatted one. How do we format it? Right. Do we think we can find examples? So let's go Rust time surday formatted. Use the well-known blah 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 when serializing deserializing offset date time. Sure, but use this module in combination surday with attribute. An example. Like, you know, just like 3 lines of code, a structure, a How? Use this module. Yes, but what? Show me an example. Uh-huh. Yeah, I mean, this is another thing. When people do these specifications like this, it's like, yeah, sure. So it starts with day of week, you know, just like an example. You know, the specification's all well and good, but just an example next to the specification would really go a long way. I don't want one that starts with the day of the week. That's silly. Internet date time format. Okay. But 3339? I mean, it's not an internet protocol. Okay, let's go with this one. How do we think we use this? Because, you know, we looked at the time crate, right? And then we looked at the... didn't we look at a book somewhere? Homepage. Survey. Okay, what about formatting? Okay, what about you know, if people spent more time writing the developer documentation instead of creating pretty websites, that might be a bit more useful. So we've got no idea how to use it. So let's have a look at the repository. Let's look for examples. Oh, there's no samples. Let's look for tests. Let's look for survey tests. Let's see. Oh, this might actually have something here. Good lord. Right, there we go, look. Not impressed. So you get... that one. Let's try it. Okay, fine. Right. So the tests we do first, and we have to use this, and then that means we have to put this here as well. Let's see what happens if we try and compile this now. Okay, so do we have to go? Surde well known? Was it in that? It was. Okay. Yeah. Okay. So now let's do that again. What did that do? Let me remove it. Huh. I wasn't expecting that. Houston, we have a problem. Okay, that's very unexpected because the test passes. So what on earth is going wrong there? I mean, all we did was add that module. We all we did was that. Because the first time we ran it, before we made this change, it says create operation. Oh! It's because it's already completed. That's why I didn't do anything. Okay, we don't have a problem. Houston, everything is fine. But we need to go back into the project and undo the completed state for this. There we go. And now we cat it out. There we go, look. So now we've got something that is machine readable, but it's now in a non-sucky format. Which is fine. This JSON file isn't pretty. I'm gonna add a note. To do, use pretty format. Right, because you got to writer and you got to writer pretty, but unfortunately you can't specify the indentation level for the pretty thing, which would be really nice just there. As you know, like a default argument, for instance, would be very nice, but no. So let's search for pretty for a second. Right, we've got a with formatter. And we have to futz around. And this is how we save one of these. So we need to borrow these, comment that out, and then I don't know. What do I need to do? Operation history. Is it this? Something like that, maybe? Oh, okay, we need a mutable reference to the serializer, fine. Okay, so it still writes, so this is good. We're going to go back in and change this to be false again. And we're going to go to the command line and just do that again. And look at it, it says updated that time, so we know that that works. There we go, now it's pretty before. Fine. Right. Okay, what do? We poked the formatting of the dates and times, really. And we added the completed flag on it, which is what we need to do. I think we're just going to merge all this with the other one. Yeah, right. Not sure why it does this. Like, it seems to be like dependent on the editor that you're using. Okay. I need to poke the trim line spaces settings in my IDE a little bit, I think. Okay. We're just doing what we need for now. Right, we've done the to-do. Cool. We're going to amend it. Done. Okay. Now what do we need to do? Well, let's close everything. What do we need to do? We need to make it not broken. But we don't really have a way of doing this in the tests yet. Okay, let's go back to the planner tests, right? Where we record the placement operation, because this is the thing we're trying to actually do, right? And we've got this operation history asserting stuff, and we've got this file message and all this stuff, right? So let's grab this, and we'll say that when we place this thing, something's going to appear in the log file. I'm not exactly sure where it's going to appear yet, but it's going to say updated. Right. And then we need an expected operation for this phase. Now at the moment we've only got load PCBs, so placement operation. Well, there's going to be more than one operation, in fact. And it's going to have an object path in it. And it says this one is going to be updated. And R3. Right, so yeah, something like that. Place true an object path, right? Because the operation is placed. Well, how about we go operation and put place there like this instead of these Boolean things. Because the operation is what we're recording, really. So let's fix that. This could be an enum, but you know, let's get funky with it. Yes, I know this thing is very long. Do we need to compare it? Yes, we do. Do we need to serialize it? Yes, all of these things. Right. Placed. Sure. That's what we said we want. Fine. But this is not one of those. It's very long, that is, isn't it? That. We might have to review the name of that. Right, so we've got this expected operations, but we're not doing anything with it. You see, let's go top 1, comma, because we need to verify the phase. We could create a little structure called an expectation. If there was more than a couple of things, I might be tempted to do that. Right. And then we want to do this sort of like contains all thing or something like this. Yeah. Yeah. I just like ordering of the expectations and all this kind of stuff. Deary me. Oh. And then this is going to be phase, and then expected. I mean, we could assert the whole lot, or we could just look for the new ones. But we could just keep popping them off the thing, really, I suppose. How about if we say, this is, yeah, let's say match. And we create a tubal struct like this. Right, and we'll put some logic in the test. But you know, it's declarative and it's not the end of the world. I think we're missing brackets. Match. Well, I guess this is going to be expectation operation, something like this. Criterion. How about expectation? Yeah, that's probably better. What else? let's say unreachable and match, or should we say compare? Require. If we require it, then right, and then we do the asserts, these things. Plop. There we go. Something like this. Right, and at some point we can extract this to a method and it'll be a little test helper and everything's going to be fine. Right, so the phase is supposed to be, and that's, we can say expected phase like this. Now if it fails, yeah, we could just assert them both at the same time, right? Yeah. Assert EQ, and then we create a tuple structure of the first operation and the first phase, but the other way around. And we assert that tuple structure is the same as the expectation. Done. But we need to unwrap this. And we need to put an exclamation mark here. And that's not totally hideous. Except that this needs to be a string. But we got a string and yeah, we got. Can we do this? No. And we need to keep doing this in the loop, right? And then we've got the operation history, and then we just set the remainder to it. So we take one off, and we grab the next one. And this can we go? No, not quite sure what to put here. Might be able to do it like that. Yes. No. Close. Expected type found a variant. What? Oh, duh. Can I move out of shared reference? Okay. Oh, but now it comes back. No. How are we going to do the assert? So it's moving this out of here. Ooh, wait a second. How can we do it? Can we do that? What do we want? Found expected tuple. Yeah, okay. So we're creating this. Cannot move out. Okay, we can. It's only test code. Maybe there's a better way of doing it. Okay, right, what happened? So it said updating phase status? No. Now, I don't think it's going to do much yet. Because we haven't written the production code, right? Yeah. So we're probably good to go and write that now. Because we're not loading the history at all. And we're not recording we're not recording anything. So, yeah. So we need to do the same kind of thing as this. So I'm just going to borrow the whole lot, copy it, and then refactor it in a minute. Right. Now the planner record placement operation, update placement operation. This is where we do it. And if it was modified, we need to update the states and also record that it was done. So we're going to schlep it in there. Now, the problem is now we don't know which phase this was for. Which is very annoying. Okay. And it seems that we need to do it not here. Yes, I know, this is going to be hideous. Don't worry. Right, now we're looking in the right place. So if the operation is placed, I suppose we can create the history item somewhere here and then write it somewhere else. Okay, so let's paste that back in here. and we're going to make it an optional history item. So we're going to go let mutt history item. Right. And then what we can do, depending on what operation it is, we can do stuff. So here we create one. But we know which type it is, so we just create one. We've got the operation here. Oh, was that supposed to be item here? Yeah, yeah. So the operation is history kind. And then we've got these ones at the moment, but this isn't what we want. So we need to do the other one, which is, we said was going to be placement operation. I think we've already got this as something else. Process operation kind. But this is a process operation. Oh, maybe we don't have it. No, we don't have it. Fine. It's new. But wait, hold on. We do have it because we've got this placement. We've got the placement operation. I knew we had it somewhere. Placement operation. Why is it complaining? Debug's not implemented for placement operation. Sure, we can have that. It needs to be serializable and everything now as well. Look. And comparable, and yeah, all the rest of it. Fine. Ah, I updated the wrong thing. I hate it when I do that. That's so annoying. That's better. That's better. So why is it complaining? Serialize, deserialize. There we go. Production code doesn't yet need deserialize. It's going to in a minute though, so we'll leave it. Yeah, okay, fine. Now, where do we get to? I don't remember where we got to. Somewhere. We've got some code that we were working on. Keep going back until we find it. Here it is. Project. The hunting problem is growing. Right. So it's going to be one of those. Right. But we don't have this phase reference yet, which is a bit of a problem. We've already got the object path, and what else do we need here? Have we got the operation? We've got the operation. I probably need to clone that. Yeah, probably need to clone the object path as well. Expected string found object path. Yeah, that's probably wrong then, isn't it? Yeah. Sure. Alright, fine. Okay. But we still haven't got this phase reference. Yeah. Let's see if we can work it out from the placement state. What's in placement state? Phase. I knew we had it somewhere. It's going to bitch and moan. Like that, probably. Right. Now, what are we doing here? Okay. Well. This is annoying. Because when you're updating the placements, you don't actually have a phase on the command line. Now it might be that we want to add one to it, otherwise this is going to get very complicated. And we need to write multiple ones of these. So let's create a map. So this is going to be a hash map of a phase reference and a vector of these. Good lord. Right, so we've got this history item and we need to stick it in this map given the phase reference. Sure. So we're going to go history item map dot entry and then go let's just see what happens when we do this. And then we're going to go dot and modify or insert no, and modify, but there's nothing in the map. We want to add something into the map. Because we've got the vector and we want to put the vector in it, and it's like, or what if we go all default, right? And then all default gives us the entry back again. Good. And then we can go items, probably history items. And then push the history item to it. Well, yeah, this is a mutable one. Okay, we're good. Yeah. But it's not sum anymore. It doesn't need to be sum. Okay. So we're good there. Let's create the phase here. Let's go phase. And let's clone it everywhere we need it. We might not need it there. We should be able to... Okay, we do need to clone it here as well. Fine. Okay. Okay, so now we've got a map. We can iterate over the map and then write multiple log files. And then we've got to load each log file up, and then what a faff. Okay, so we can go for phase reference items in, and then it's the history item map. And then we do this inside here. Okay. But we want to extend it with the items. I think. Something like that. And then we've got this path. We still don't know the path, but that's not the end of the world. Okay, because update placements doesn't take a path yet, but it will do. When I steal the argument from here. Here. Which I believe is in here. Okay. Object path, object path. What's wrong with that? We don't have any. Oh, we need to. Where we use object path, we have to futz. We have to use this. But before we can use that, we have to do this. Right. Right. But before we can use surday as, we need to use the surday as thing. Okay. Which means we're probably going to need an import for that as well. Which we should probably find at the top of another file that uses it. Here. Oh, I've already got it. What's the problem? Let's just write. Oh yeah, okay, fine. We missed that one. Fine. How about now? There we go. There was an unused thing. Unused variable operation history. Well, that's interesting. Why does it think that's unusable when it's in a loop? Is it because this namespace is after this one and this one always refers to this one and this one is just unused in this? It probably is, isn't it? Remaining. Let's do this then, I suppose. And I guess we need to make this mutable now. But this gives us a slice. Yeah. Oh my god, it worked! No. Let's just dump these out, look. Println, whatever. Do we trust that they were there? Do we trust that the asserts were completed? No. No, we don't. Now, the one that we're doing is this one. I mean, there's a history item, and it says phase top 1, placement operation, yada yada yada, test operation history item, yada yada yada, placement operation, R3. Let's put is there a not equal? Oh, it's NE, isn't it? Let's just try that, just to see it fail. It does indeed do it. Yeah. It is actually working. Sometimes you don't believe that you get it right, but yeah. Cool. Okay, let's extract this real quick to a method, which is going to be something like assert history, assert operation, expectations, and then the history. Let's move this down. This is what you want to look in, and this is what you're looking for. Haystack needle. I don't know. Needle in a haystack? Haystack in a needle? Ah! Okay. And we know that it's not going to be able to do that. That's redundant. I think that's redundant in our other test as well. Let's check that. Because we borrowed it, yeah. We don't need that assert anymore. It's redundant. Because we're already getting something out of it, which wouldn't work if there wasn't something there. Okay, let's run that again. Oh dear, we broke it. Okay. We don't really need a mutable reference here. We just move it over there and make it mutable. Yeah, that's better. Because once we've done it, we that's it. Yeah, okay. That still works. I suppose here we could actually say that it's the only entry in it. I've got a better idea though. Because we've got our new little way of asserting things. This, right? And then we could have EOF like this. Right? To say that there are no more. We can go remaining operations history. We can do this, look. EOF assert is empty. With some brackets. Okay, so let's make sure that works. Unwrap on a none. Why is it going unwrap on a none? Oh, and we need to stop. Do we? No. Why is it doing that? Oh, right, yeah. So if it's EOF, you shouldn't continue the loop anymore. We should break. Right, and you know that there's nothing else to do because you've just asserted that it's empty, so there can't be anything else in the list. It has to be the last one. But why doesn't it work? Why is it unwrapping on a none again? Why? What's wrong with it? Because I'm not sure. What if we go no. Why is it going wrong? Unwrap on a none. Split first is returning none. Why? Let's just make sure it panics here now. I'm not seeing unwrap on a none again. Why? Why is it doing that suddenly? Let's just comment that out for a moment. Okay, because it's got to the require and therefore, right, okay, fine. So there is none in it, right. Okay, now that makes sense to me now. This shouldn't be remaining operation, this should be this. This bit should only be done here. And no, we need to do it in a different way. God damn it. If let's just do another match and just move this one up to here. And we'll let Clippy do a warning. Go. There we go, that fixed it, right. Okay. So we've got a way of looking at all the things in it and skipping things as we required. So we've got this assert operation history. So we can use this same assert in our previous test. This one. Right? Here. And we can delete this. We'll comment it out first. And we'll go to our other one. And we'll grab the list. And we'll put it here. And we're going to say that we expect this. And then an EOF. Right? And we use the same logic to check all the different things. That seems pretty good. There we go. So, now we can get rid of this, and we cleaned up the test code, and we've got a little helper, and we're going to assert all of them for now and forevermore, and everything's fine. Okay. Okay. So finally, everything's done. No, it's not done though, is it? Because Houston, there is a problem. How is this possible? The reason I'm saying how is this possible is because nothing is writing. Does it? I'm very confused by the content of what is in this. Yeah, we might have a problem here. I'm not sure whether this is... Okay, look. Because what we're saying is there's supposed to be 3 things in it. The first one we ignore and the other 2 things are supposed to be there. But the reality of the situation is we've got a history item and a history item and then nothing else. So clearly this isn't working as we expect. So let's println the first. So what's going on here? Why is it doing it 3 times when there's only 2 things in it? Oh, right. It's because of the position of this, isn't it? We always need to do that. Right, now it's going to fail. No, can't do this because it's borrowed. I guess there's nothing to actually do here. Hold on. Let's put it back. And instead of putting continue there, we just do nothing. And then we do that. And then we don't have the borrowing problem. Right, now it's failing properly. Because it skipped over one of them. Right. Let's go index. Why did it do that? And enumerate. Now, what's going on here? Do we need to do... Do we need to do that? I think we do. Why is it not like that? What's the problem here? What have we got to do here? I don't want to clone this. And now it's going to bitch about this. Expected tuple, because that's what we've got here. So now perhaps we go like this. No. We still need the clone. I don't want to clone the other one. Okay, fine. Right, now it should fail for the same reason, but now it should print out the index. There we go, look. Okay, good. And this should be item really here, shouldn't it? Let's go with that. Right, does it print out something that's nice now? There we go. So index 0, expectation, ignore item and then the details of the item. Good. Great. And it won't print out EOF. But that's fine. Okay, good. So, the problem we've got now is that we're overwriting the file every time, which is no bueno. So, we've got this write thing here, and where we call write, we do this. But the problem is, we don't load it in ever. So we need sort of like the opposite of this thing. So if we say operation history in read or default. But I think we're going to need a bit more than that. We're going to need a path. Right. So if it's a new one, seems reasonable. Otherwise, we have to deserialize stuff. So I suppose we go surday JSON from reader and we give it the file, but we want to open the file, and we're going to do the same thing here, kaplop. And then, well, this can fail. So this needs to be probably a result of something. Oh, that might be right. And here we need to return OK and then whatever. And from reader gives us a result already, but it's probably the wrong type. Found result of whatever, but found result error surday JSON error result. So we just do that. Operation history, I suppose we called it. Okay, so here we can put a because it might still fail. But oh, we need the path. Duh. Well, we have to move this up, pull that down, and then put the phase log path here, right? But we need to clone it because they both take it. But this can take a reference to a path buffer, right? Because we're cloning it here anyway. Yeah. So that can be avoided here. Cool. Okay. And then I guess we need to do the same thing in that other method that was doing stuff with the history, which was this bit, right? like that, I think. So we get the phase log path, we load it up or read it in, fail if it doesn't exist, and then write it. Yeah. But the test will still say that they expect a particular message. So this one here, you know, we've got asserts for this. So we can actually now add an assert for this to make this more exact. And that passed, which is great. So somewhere in here, oh no, we've already got the assert for it. Let's check that. So we've got setting place flag, updated operation history, yeah. And then we have the asserts, and if we go down to the bottom, look, this is the original one that was missing before. It's working. It's working. We did it. We did it. We did it. It only took 3 hours and 43 minutes. But look. I'm ticking it. I'm doing it. It's done. There you go. Ta-da! We finally did it. Okay, let's do a commit. So what did we do? We logged placement operation histories, didn't we? Yeah. Log placement operations. When placing placements. Yeah. What a faff. Okay. I guess some of the other things we did was refactor operation history assertions. Right, because that's what this was. That's what we had to do to add it. And then we had loads of fun with placement operations that go in the log. And it's done the usual white space malarkey. What file am I looking at? Operation history, this one. And then we had to add survey stuff on there, which is fine. And we had to build a map of these things. That was quite a faff. And there's probably some refactoring that we can do, because there's a bit of duplication. And we added the path argument there, that's fine. So it's all good. We're all good. It's done skidoo. It's done skidoo, we did it. We did it. Okay, let's run all the tests. In both modes. Are we good? Look how quick that is. That's pretty good. Okay. Oh yeah, it won't do it. I was just going to test it on this, but we need to poke the placement state and all this kind of stuff in our little project file to see it in a real world test. But it's not the end of the world. Let's say it's false. And let's just randomly do placed true, placed true, placed false. So we're going to pretend to place that one as well. Okay, cool. So that's what's in it. And then we're going to do another thing, which is record placement operation. And then we need the path object, path patterns, and it's going to be that. Setting place flag, updating phase status, phase operation incomplete, which is fine. And it created an operation history file. And it turned out that component was on the bottom. So really I want to pretend to place one on the top. Let's have a quick look. Bottom. Here's one that's on the top that's not placed. Let's do that one. So now it's updated this one. There we go. Ta-da! It works. Let's eyeball it though. I mean, I say it works. We've got date time, we've got phase, we've got operation, phase here is correct, operation load PCBs, completed, placed, yada 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 yada. Looks pretty good. Let's pretend to place all the capacitors. I think we might have a problem. I might have to look into that. No, it doesn't look right. Oh, it's because I went. I got my regular expression wrong there, I think. I'm a little bit weirded out by that. Like, what? What happened there? And why isn't it printing out C101? Is it something funny with my shell? That's a bit weird, isn't it? Okay. Because, you know, that pattern should match this, right? Let me just go C102. I'm not sure if it's pulling the patterns out there properly. What happens if you put this around it? Unexpected token, yeah. Okay, I think there might be some weirdness going on with the shell. There's something funny going on there, isn't there, for sure. Okay, well, I'll delve into that and see what's going on a bit later on, I suppose, because it's a bit weird. Because we know the tests work, because, we've got tests for that, haven't we? What's going on? I'm confuzzled. Right? Because we have chord placements operations. Right? Object path patterns, and then we've got here's an example. So regular expressions are working when they're run from the IDE, but on the command line there's some funniness going on. Yeah, I'll delve into that and see what I can see going on with that, because that's unexpected. Yeah, okay, alright then. So, just remember folks, it's only software. How hard can it be? We'll find out on the next one. See ya!